Alright, let's do online assessment. Start. We'll have two questions and have up to 1 hour to complete. Okay, two questions. Let's see the first one. Given an ampersand grid where each cell can have one of the three values. There is a grid and each cell can have 0, 1 or 2. 0 means empty, 1 means an orange, a fresh one, and 2 means a rotten orange. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. Nice. Return the minimum number of minutes that must elapse until no cell has fresh orange. If this is impossible, return -1. The only way this is impossible is there is no neighbor, right, of a rotten orange. If rotten orange is completely isolated, then uh, then that would be the case. And so we have to find if no cell has a fresh orange. Minimum number of minutes that must elapse. It could also be minute 0 if there are no fresh orange to begin with. So you want to know how many fresh oranges are there. So to begin with, this was a rotten orange, then these two became rotten, then and these two became rotten, and these two became rotten, then everybody became rotten. Interesting. So you're only interested in rotten orange. I mean, you can initially you can keep track of how many fresh oranges are there, how many rotten oranges are there, and how many empty oranges are there. Empty you don't care about. So if you're not already connected at any point, this is not an easy doesn't look like an easy problem. Let's come to it in the second step. Let's do the other problem first. What is this? Given a positive integer n, generate n cross n matrix filled with elements from 1 to n square in spiral order. So n cross n, you'll have this, yeah. We have to generate this matrix 1 2 3 4 5 6 7 8 9 like this. Okay, so you know the start value, you know the end value. You just traverse the matrix in a spiral order and keep adding the value. So that's easy. I think this is easier. So let's do this first then, if it's easier. So you go okay. Now that's fine. Now you go in 4 directions. You start with right first, then you go down, right, then you go left, and then you go up. So you start with obviously going right, and you have 4 boundaries. So this is 0, this is -1, this is 0, this is -1. Fair enough. Then what happens? Hmm. Give me a sec. Let me pause here a bit. All right. So what you gotta do is let's print the first guy, right? So let's do grid I grid 0 0 equals to just let's do it 1. Let's do count well plus plus. Then switch with this T. This is the first case. So you're gonna do you're gonna go from left to right, so you're gonna go from okay, so let's not do that. Okay, so here you do what? You do grid of, so here the top row and I equals to val plus plus, and once you're done with this, you do top plus plus. And you do count plus plus, start with count equals to 0, right? And so you're gonna do this while count is less than n times n or equals to n times n. Then you keep doing this. Okay, so now if you're going down, what you want to do, you want to from top to bottom. So for equals to top is less than equals to bottom plus plus grid of okay, so row is this, row is I, and right equals to val plus plus count plus plus. I mean, you don't really need count, right? You can just do yeah, I think this is fair. You can start with val equals to 0, you can do plus plus val. No, you don't need count. So you remove count. So you go from top to bottom, you do right minus minus, you do direction dot hold on, yeah, direction dot left and break. Now you do case direction dot left. What are you gonna do here? So you do minus minus, you do grid of bottom uh, I equals to well. So you're done with the bottom row. So the bottom minus minus, no? And you do d equals to direction dot up and break, and finally here you go bottom to top, left to right, right to left, I equals to 0, I is greater than equals to top, I minus minus grid I of left plus well, you go to top, so you go top plus plus. No, so left is done, top right bottom left plus plus, and direction becomes break. Right, all this is done. Now you want to return after this while loop, you want to return this grid. How about that? Let's run code. Got a compilation error, line number 44. Anywhere else? All good. Look, cannot find symbol. Okay, I mean that's what I'm doing here. Fine. So you do this, run code. Switches level would be unqualified of an enumeration constant. What does it mean? Should I put like that or what? cannot do switch case, I can do if else. But let me see what's the issue here. Must be unqualified name of an enumeration constant. Switch case label must be, yeah, okay. So what does it mean? Don't fully get it. Does that mean I don't need to use like, does that mean I can just do write and it will figure it out based on the type? Okay, it does. So test out one more thing. Can I also do this then? No, it doesn't. See, it's so stupid, huh? Okay, one example test cases. 123894765. Okay, let's submit. Okay, this one works. Let's go back to first question. We have almost half an hour left. Let's see if we can do it in that much time. So I mean, this is graph. You do BFS, DFS, or you do connected components, or you do distinct set union. One of those has to work here. Every day more and more cells become bad. How do you represent it? Let's start with the union find. Okay, so in union find on day 0 you have the state, and you know that you can check whether or not there is any fresh orange or not, right? And there is a fresh orange, that's fine. So on minute 1, how do you go about spreading? How do you go about spreading? So that's a bit on every day or on every minute, whichever are bad, so you find out whichever are bad. Hmm. Okay, let's do brute force. We don't have time. Let's do brute force. So basically, yeah, every day you go on the previous state, you incrementally do that. So you maintain what a list could just grow. Hmm. Is it just BFS or something? Is it just uh, so like let's say if you try BFS, initially you put all the bad, so initially you just put this guy, right? And you start with this, and the next level is this. It has to be level order traversal, right? And then in the next level more things will happen, in the next level more things will happen, sort of a level order, or like a BFS. Fair enough. So let's try BFS approach. Yeah, sure. So this is fine. Now you want to start with a queue of int, queue of int, queue of int new linked list. Okay, so you start with a queue. Now what are the source of the queue? Source of the queue is so there are a few things that you gotta do. One is go through each row once. So for each int row in grid, if grid of sorry for each int row, for each int cell in row, yeah, I have to use ij. For I equals to 0, I is less than, and I plus plus, j equals to 0, j is less than grid of yeah, so if grid of ij is equals to this is an empty cell, this is a fresh orange, so if it's a fresh orange then you do fresh plus plus, right? If it's an empty cell, don't do anything. If it's a rotten orange, at this point you will add it to the queue. Initially all the rotten oranges have to be added to the queue, so queue dot add new and Is that the right way? I guess so. Let's do that. So this is your initial state. Now you do, if to begin with, if fresh is already 0, then you just return 0. And then you do okay, you want to keep track of visited as well. How do you do that? Make it -1 or something. Okay, so you get the cell. Now you go to each directions. You're gonna do so now if it's in the grid, and if it's a fresh apple, only then I'm interested, right? So a fresh apple, grid of if it's a fresh apple, then that means it has to be 1. Well, then you decrease your fresh, and if fresh becomes 0, you return this time. If that's not the case, then we continue. You do make it visited, you add it to the queue, and that is it. So this is the next level. And keep doing that, and if the fresh has not become 0 at this point, you return -1. So that's my strategy. Let's run. Okay, you do get 4. 4 -1 and 0 is the answer. 4 -1 and 0. Okay, submit. Okay, it works. Let's talk about the time complexity here. Okay, let's just submit. Okay, finish session. Okay, both were mediums. So what's the time complexity here? What happened? Okay, yeah. So what's the time complexity here? So we first go through the grid. Grid is m cross n. Okay, this is quite good. Let's look at this again. So we go through the grid. We create a queue. So the queue's size would be m cross n. And really we are essentially just doing a what do you say, just a BFS, right? It's essentially a BFS, so time velocity is m cross n only. Alright.